Okay, boys and girls, this is the second part of chapter 6-6, and we're going to be looking at how to find the x-intercepts of quadratic equations in two variables. Now that sounds really complicated, but I promise you it's not. So first let's start with x-intercepts. What do we know about the ordered pair of the x-intercept? Well, let's slow down. Which one is the x-intercept? So remember, this is the x-axis and this is the y-axis. So the x-intercept is going to be this point right here. And let me make that a little bit darker here. It's going to be this point right here. Alright, so what do we know about that ordered pair? Something comma something. Remember, it's x comma y, so that's going to be -1 comma 0. Let's look at the x-intercepts on the second graph. We have an x-intercept here, and we have an x-intercept here. That first one is going to be 1 comma 0, and the second one is going to be 3 comma 0. Now those are three x-intercepts. What do you notice is the same in all three of them? You guessed it, y is equal to 0. So what we know about the ordered pair of an x-intercept is that the y is always a 0. So if we want to find the x-intercept, all we have to do is plug in a 0 for y. So this says, find the x-intercepts of the graph y equals x squared minus 5x plus 4. So to find an x-intercept, substitute y with 0. Okay, so instead of y, we're going to have a 0 equals x squared minus 5x plus 4. And now all we have to do is figure out what x equals. Well, this looks awfully familiar. Doesn't that look like what we were solving just last week? It's a quadratic equation. To solve a quadratic equation, the first thing that you want to do is make sure it's equal to 0. It is. Then you want to factor it. It has to be a times b. So I'm looking, this has an a equal to 1. There's no GCF. It's not a pattern. Or is it a pattern? That's a number squared. That's a number squared. Oh, but the middle term doesn't work. Okay, so we want factors of 4 that add up to -5. So that's going to be -1 times -4. So that means we've got 0 equals x minus 1 times x minus 4. Now I'm going to do the zero product property. Either x minus 1 equals 0 or x minus 4 equals 0. Add 1 to both sides. So x is 1. Or add 4 to both sides. So x is 4. So the x-intercepts of the graph are 1 comma 0 or 4 comma 0. Remember, an x-intercept always has a y value of 0. Those are our y values of 0. And we found the two possible x values. So those are my two possible x-intercepts for that graph. Let's try one more. Find the x-intercepts of the graph y equals 2x squared plus 11x minus 6. So again, in order to find an x-intercept, the y has to be 0. So instead of y, I'm going to plug in a 0. And now all I have to do is solve for x. I'm going to make sure it's equal to 0. Look for a GCF. Take the look to see if there's a pattern. Well, must be the long method then. Looking for factors of negative 12 that add up to 11. How about negative 1 times 12? So that means we have 0 equals 2x squared. Split that middle term into negative 1x plus 12x minus 6. Do some grouping. We can divide by an x, and we can divide by 6. So it gives me 0 equals 2x minus 1 plus 6, 2x minus 1. So 0 equals x plus 6 times 2x minus 1. I have it factored, so now I can do the zero product property. Either x plus 6 equals 0 or 2x minus 1 equals 0. In solving it, I find out that either x is going to equal a negative 6 or add 1 to both sides, divide by 2, x could be 1/2. So my ordered pairs then are negative 6 comma 0 or and there's 2 intercepts 1/2 comma 0. Those are my x-intercepts. So anytime you have an equation that looks like this, the graph is going to be a U-shaped graph. That's called a parabola. And when we're looking for the x-intercepts, those are the solutions when you plug in a 0. So this is just kind of a little summary here for you. It is possible to get no solution. And the way you would get no solution is that you cannot factor it, that it is prime. It is also possible to get one solution. That's going to happen when it's a perfect square trinomial. 2 solutions is the most common result, and the U will either be smiling or frowning. All right. So let's take a look at some equations and matching them to their graph. Remember, in order to find the x-intercept, all we need to do is plug in a 0 for y. So in the first equation, I've got y equals 2x. Hold on one second. Okay, sorry, I had to decide which problems to do because I realized I don't have 6 possible answers, so I needed to make sure the right problems were done. So let's do 84. So remember, if we plug in a 0 for y, then this has already been factored for us. So either x minus 5 is going to equal 0, or x plus 2 is going to equal 0. So that means x either equals 5 or x equals negative 2. So which graph has x-intercepts of 5 or negative 2? D does. So 84 is the graph of D. 85. Again, plug in a 0 for the y. Either x is going to equal 0 or x plus 3 is going to equal 0. So which graph has an x-intercept of 0 or and negative 3? That's going to be B. The last one's a little tricky. 87. We've got y equals 2x squared minus 8. In order to factor this, we need to go through what we know. We can factor out a GCF. We could go through that normal factoring. But I want to show you something that you could also do. We're going to plug in a 0 here. So we've got 0 equals 2x squared minus 8. Since there's only one variable, Notice in the other problems we have two variables, which makes it tricky. Since we only have one variable, we can add 8 to both sides. That gives us 8 equals 2x squared. We can divide both sides by 2. That gives us x squared equals 4. What numbers could I plug in for x that would give me 4 when I square it? Remember, 2 squared is 4. So x could be a positive or a negative 2. So that's the example, the graph, letter C. Okay? So, anyways, what I'd like you to do now is practice this idea. It isn't much different than what we were doing before. Just gives you a chance to practice and go a little deeper with it. 6B on My Math Lab.